Today's lesson is going to focus on roots and radicals, and this is kind of the opposite of our last lesson, which focused on exponents. So what's really nice about this is that we get to use what we know about exponents, but just kind of reversing the process. So let's look at, all right, what we think of as roots or radical. Okay, so when we apply an exponent to a number, all right, we are multiplying that number by itself a certain amount of times. So for example here, when we look at 2 squared, we know based on our discussions that this means 2 times 2, and we're looking at that being 4. All right, so a root or a radical, all right, so we call this a square root, and you may see that it's called a radical, all right, is saying, okay, so when we see this, it says, what is the number, all right, multiplied by itself twice to get us to 4. So it's basically saying what number squared is 4, which could be 2. All right. Now, what we're going to talk about in just a second is that when we get to this, notice when we start with an exponent, all right, we know what the base is. This is 2 squared is equal to 4. So we know for a fact what our base is. But notice when we're reversing this process, we're taking the square root, and we're asking yourself, okay, what number times itself could be 4? Well, we know 2 times 2 is 4, so that's definitely an answer. Well, what we also should remember from our properties of real numbers is that there's a second way to get a positive number when multiplying, and it could be negative 2 times negative 2, which is also 4. So a lot of times when we do the square root of 4, we'll write 2 or negative 2. Since we're reversing the process, we don't know for sure which number we started with, so we're going to write both of those down. Now, so when we did 2 to the third equals 8. So we have 2 times 2 times 2, and that is, in fact, 8. Now, when we do the cube root of 8, okay, now once again, this number here, notice we don't see it here. All right, when we don't see that number, it is implying that it's the square root, okay, which is the opposite of squaring a number. So this is saying what number, when we multiply it 3 times, gives us 8? And the answer in this case would be 2. Now notice this is an odd root versus our first one, which was an even root. And notice there's only going to be one answer when we have an odd root. Because notice if we have 2 times 2 times 2, all those numbers are positive, so therefore we would be 8. However, if we try to do negative 2 times negative 2 times negative 2, notice a negative times a negative is a positive, and then a positive times a negative is a negative, we would get negative 8. So with an odd root, we will only get one possible answer. All right, so let's go to this one. 2 to the fourth is 16. So once again, we know what base we're starting with. All right, so that's 4 2's that multiplies to be 16. Now once again, we see the number here is saying what number, when I multiply it 4 times, will give me 16? Well, obviously, if we look at the example we just did, we could do 2 times 2 times 2 times 2, and that would in fact be 16. But we could also do negative 2 times negative 2 times negative 2 times negative 2. All right, and if we look at that, negative 2 times negative 2 is a positive 4. Negative 2 times negative 2 is a positive 4, and then 4 times 4 is 16. So we have 2 possible answers on this. So the important part is that let's look at that, all right, that even root, and know that we could have 2 ways of getting to that number, the positive version or the negative version. All right, so now, when we look at this, and I've already basically covered the next slide, getting in that again, but when we look at that again, all right, so we look at that square root of 4 again, remember that there's 2 ways to multiply to get to a positive 4. We have this guy, and we have this guy. So just remember, this is going to apply, all right, to all of our even roots, because we'll always be able, if it's an even root, we'll always be able to pair those guys up, and then they'll always work out to be a positive number when we're multiplying. All right, so let's look at, all right, how you should write your answer. All right, so when you do this, all right, so whenever we have this even root, oops, let me go back here, clicked on that. Whenever we have this even root, we want to write both possibilities, 3 or negative 3, 2 or negative 2. Now, if by some chance, all right, we have a negative number inside of the radical here, what we should know is that we can never ever take an even root of a negative number. Remember that this is saying what number times itself, all right, can be negative 9. Well, I can either do 3 times 3, well that gives me a positive number, or I can do negative 3 times negative 3, which also gives me a positive 9. So they have to be the same number. Notice the only way to multiply to get a negative number is I have to have one positive number and one negative number. Well, if I want the same number twice, it can't be this possibility because that's two different numbers, so that is out. So what we say is that there's no solution if we end up with the square root, all right, beneath, or sorry, let me say that again. If we end up with a negative number beneath our square root radical or an even radical. Now, what happens whenever we have an odd root? There will be one and only one solution. So what number times itself 3 times will be 27? Just 3 times 3 times 3. Because notice, if we did negative 3 times negative 3 times negative 3, that's positive 9, and then that would give us, I'm sorry, let me put that other negative there, doop, doop, and that would be negative 27. So we can see that this would not match this guy. So one and only one solution. All right, so what I'm going to do now is just give you a few problems for you to work on. So go ahead and pause the video, all right, and see if you can find the answers to these problems. All right, so let's look at these real quick. Now, the first thing you should think about is whether I have an even root or an odd root, so I know how many things I'm looking for. So remember, if there's no number here, this is really a 2, and it's asking for the square root of a number. All right, so what number times itself twice gives us 25? So that could be 5 times 5, all right, or negative 5 times negative 5. All right, so we have our two solutions. All right, now when I look at this, this is asking what number times itself 3 times will be negative 8. So since it's an odd root, we're going to have one and only one number. In this case, it's negative 2. Now, once again, what's nice about these is you can check your answer, just multiply it out. So I've got to do negative 2 3 times. Okay, put that negative there. So that would be positive 4 times negative 2, and that is, in fact, negative 8. So once you write your answer, all right, you can check it very quickly. All right, now, once again, we go to 1 here. We have the fourth root of 1. Since it's an even root, there's going to be two possibilities. And so in this case, what times itself 4 times will be 1? Well, 1 or negative 1. All right, moving on to our fourth example here, we have the square root of 100. Once again, we're assuming this is a square root since we don't see a number here. So what number times itself would be 100? So we have 10 or negative 10. So 10 times 10 is 100. Negative 10 times negative 10 would also be positive 100. And then we look at, all right, didn't see our last example here. When we get down to this guy right here, we have an even root of a negative number. That's not possible, so we're just going to say that's no solution. All right, the fourth root of 81. So what number times itself 4 times will give us 81? That would be 3, all right, or negative 3. All right, so this is just a very quick lesson, an introduction to your roots and radicals. All right, so now you should be finished with both lessons, all right, for lesson 3. So now you should be able to move on to worksheet unit 03. Once you're finished with that, come check in with me.